The coefficient of x to the 12 in this polynomial is one of these numbers. Okay. So, you know, I don't want to manually expand this, of course. I suppose we're just using some kind of version of the binomial theorem and trying to keep track of where powers of x equal to 12 could come from in each of these terms. Let me write out the polynomial. 1 minus 2x to the power of 5 times 1 plus 4x squared to the power of 5 plus 1 plus 2x to the power of 5. I notice that this is something raised to the power of 5. So let's factor that. You know, I don't know if this is exactly the right way to do this, but I'm going to factor that out first. 1 minus 2x times 1 plus 4x squared times 1 plus 2x, all raised to the 5. So I notice I get 1 minus 4x squared times 1 plus 4x squared, all raised to the 5. And that's 1 minus 16x to the 4, all raised to the 5, which can that give a power 12? I suppose it can, right? So let's call that y, right? 1 minus 16y to the power of 5. And I want the coefficient of y cubed. Okay. So y cubed, oops, sorry. I mean, I can write this as the sum. K goes from 0 to 5 of 5 choose k times 16y to the power of k. Negative 16y to the power of k. So when k is equal to 3, I have 5 choose 3 times 16 cubed with a negative sign. Okay. 5 factorial divided by 3 factorial, 2 factorial times 2 to the 4 cubed. This is 5 times 4 divided by 2 times 2 to the 12. 5 times 4 times 2 to the 11. Where did my minus sign go? So this is 2 to the 13 times 5. And that's option A. So I hope I did everything correctly there. I'm also, you know, that should not be a plus sign. We're multiplying these all together. Sorry if that confused anyone. That should have just been straight multiplication. Yeah, the fact that these are all raised to the power of 5 obviously simplifies this a lot. And they've obviously chosen each of these individual terms such that we have a lot of difference of squares type thing going on. So we in fact only need to use the binomial theorem once. But, you know, the exact same question could have been asked with, you know, 3 terms in here that don't multiply together so nicely, or with different powers on each of them. That's what I thought this question was leading towards at first. And that would have been a pretty tedious mess, I think. So I'm happy that I saw very quickly that these simplifications worked. Yeah, and if they had asked for a power of x, which is not a multiple of 4, the answer simply would have been 0, right? When you expand this, every power of x is going to be a multiple of 4. So one of the options they give is 0 in case someone sort of accidentally comes to that conclusion based on this factorization. Anyway, I'll let you know if there's a mistake in this one. Thanks for watching.